Ever stop and think about that magic box sitting on your desk? I mean, really think about it. Well, today, we're going to peel back the case and take a journey deep inside the machine you use every single day. Let's find out how it actually works.
It really does feel like magic, right? You click a button and a whole universe of information just appears. But here's the thing. Underneath all that magic, every single computer, from the one in your pocket to a giant supercomputer, follows one simple, elegant model.
And there you have it, the input, process, output model. You give it something, it thinks about it, and it gives you something back. That's it. Everything a computer does, from playing a game to editing a video, is just a ridiculously fast and complex version of this loop. So, to really get what's going on, let's dive into the most interesting part first, the process. What's happening inside the computer's mind? You know, the best way to understand how a computer thinks is to think about, well, us. So we're going to start with the two most critical parts, which work almost exactly like a human brain and its central nervous system.
Meet the CPU, the central processing unit. This is the brain. It's the core thinker, and it's constantly running this simple little loop. Fetch an instruction from memory, figure out what it means, and then do it. Fetch, decode, execute. Over and over. And it does this billions of times a second. That's what gigahertz means. Billions of cycles per second. I mean, just try to wrap your head around that speed. It's wild.
But, a brain by itself is pretty useless. It needs a nervous system to connect to everything else. And for the CPU, that's the motherboard. It's the huge circuit board that everything, and I mean everything, plugs into. It lets all the different parts talk to each other and work as a team. And if we crack open that silicon brain, you'll find two main workers doing all the jobs. First, you've got the control unit. Think of it as the project manager. It's not doing the hard math itself, but it's directing all the traffic and telling everyone what to do and when. Then you've got the ALU, the arithmetic logic unit. This guy is the super fast calculator that handles all the math and makes all the logical decisions.
Okay, so the CPU is the brain. But where does a brain keep its thoughts? And where do you save your vacation photos for next year? Well, that all comes down to computer memory. This analogy just nails it. Think of RAM as your actual desk space. It's where you put all the stuff you're working on right now so you can grab it super fast. But when you leave for the day and turn off the lights, poof, the desk gets cleared. That's why we call it volatile. Your storage, on the other hand, that's your filing cabinet. It's where you put everything away for long-term safekeeping. It might be a little slower to get things out, but they're always there, even with the power off. It's non-volatile.
But it's actually not just two types of memory. It's more like a whole ladder of it, a hierarchy. The CPU is super demanding, so it keeps the most critical data it needs right now in these tiny, lightning-fast pockets called registers and cache, which are literally built onto the chip itself. Then, for its main workspace, it uses the desk, the RAM, and for everything else, it goes to the big filing cabinet, your storage drive. The key thing to remember is this: the closer the memory is to the brain, the faster it is, and the more expensive.
All right, so we've built a thinking machine. It's got a brain, it's got memory, but how does it see or hear anything? How does it talk to us? How does it actually interact with the real world? And this is where we come full circle back to that simple model from the beginning. Input devices are the computer's senses. Your keyboard, your mouse, your webcam, they're all just converting your physical actions into digital signals that the brain, the CPU, can actually understand and process. And then, on the flip side, once the computer has done its thinking, it uses output devices to talk back to us. Your monitor, your speakers, a printer, they are the computer's voice and its face, turning all those ones and zeros back into images, sounds, and words that make sense to us.
And what's really key here is that different output devices are built for different jobs. A monitor is for seeing things, speakers are for hearing things. And even within one category, like printers, you have different tools for different tasks. One for beautiful color photos, another for spitting out sharp text documents at high speed. It's all about using the right tool for the right kind of output.
So all this stuff, the CPU, the memory, the motherboard, all the physical parts you can touch, we call that hardware. It's an incredible, powerful body. But without a mind, without a consciousness to give it instructions, it's just a really sophisticated hunk of metal and plastic. It needs a soul, and that's software.
Basically, you can think of all software as falling into two big buckets. First, you've got system software, like your operating system. This is the manager that works behind the scenes, making sure all the hardware components play nicely together. Then you have application software. These are the tools you actually click on and use.
your web browser, your music player, your games. They're the reason you have a computer in the first place, and they rely on that system software to even run.
So how in the world do you get from a human idea to something a tiny chip can understand? Well, it's a translation process. A programmer writes instructions in a language that looks a bit like English, something a human can read. Then, a special program called a compiler acts like a universal translator, taking that human code and, step by step, turning it into machine code, the raw ones and zeros that are the only language the CPU actually speaks.
Now, a single computer is an amazing tool, no doubt. But let's be real, its true power, the thing that literally changed the world, is when it started talking to other computers.
And for that to happen, you've got this whole team of little gadgets working together in your home. The signal from the internet comes into your house through the modem. Then the router takes that connection and creates your own private network. And finally, the network card inside your computer is what actually lets your device join that network, either by plugging in a cable or, of course, wirelessly using Wi-Fi.
So, when you put it all together, the hardware brain, the software soul, the memory, the senses, the ability to connect to the whole world, you get the modern computer. It's a truly amazing piece of engineering.
But this entire, incredibly complex system, with its billions of tiny switches and millions of lines of code, it's all governed by one very simple, very fundamental, and totally unbreakable rule.
And the answer? Well, it's surprisingly simple. For all of its incredible power, a computer has zero actual intelligence, no judgment. It can't truly think for itself. It is, and always will be, limited by the instructions we give it and the data we feed it.
It all comes down to the oldest rule in computing: garbage in, garbage out. The quality of a computer's results is completely dependent on the quality of its programming and the information it's given. It's an unbelievably powerful tool, but at the end of the day, it can only ever do exactly what it's told. And understanding that core limitation is the real key to understanding how these incredible machines actually work.